Okay, so we're on 2018 Further Maths Exam 1. Still on the data part. So question 6 we're starting on in this video. So in this case, the data was collected to investigate the association between the following two variables. So which one of the following is appropriate to use in statistical analysis of this association? So we've got two variables, okay? So two variables is saying it's bivariate, okay? But we look at our two bits of data and they're categorical. I probably spelled that wrong. So categorical, so that pretty much, if it's bivariate, that automatically rules out the box plot. Okay, categorical rules out the fact it's a scatter plot. A least squares line needs a scatter plot. The correlation coefficient needs a least squares line, which needs a scatter plot. So in this case, it's going to be a segmented bar chart. Okay. Question 7. The scatter plot. So this is for 7 to 9. The scatter plot below displays the resting pulse rate in beats per minute and time spent exercising in hours per week of 16 students. The least squares line has been fitted to the data. Okay, using this least squares line to model the association between resting pulse rate and time spent exercising, the residual for the student who spent 4 hours per week exercising is closest to. So what we've got to look at here is, first part is when was it 4 hours per week. So it's this bit of data here. So it's this one here, okay? And it's below the line. So when we do a residual, remember it's going to be basically this value here, this value there, minus the actual. So it's predicted minus the actual. So in this case, I'm going to rule out D and E straight up because of that. So we consider the predicted is roughly 64 and the actual's 63. So in this case, the answer is going to be B because it's going to be minus 1 beats per minute. Okay. The equation for this, let's go next question. Equation for this least squares line is closest to what? Now, there's a couple of things we can get rid of straight away. Okay. Now, thing to keep in mind to check, is this line on 0? No, it's not. It's on 1. So if this says, if we read this and go, oh, it's 67.2, because that's what it's saying down here a bit, it's not 67.2. So we can get rid of those three straight away. Okay? Because we're looking at the fact that it can't be that, because this here is not 0. So it's not crossing at the y-axis. Okay? So that's where we can rule out that one straight away. So how do we get the next part? So at this point, we're looking at the gradient. And so here we just need to basically look at a gradient. All right? So let's look at 2 points that we can pick up from here. So I like to pick up where I like to call sort of the crosshairs, or where we know it meets. This part here, we can go from that and we'll go down to the 65, go across. Okay, so this is going to be 1.2 long and this is going to be 1. Oh, sorry, 2. Okay, so I just realized I made a slight mistake. Not 1.2. Hopefully you picked it up before I did. It's 2.2 because I knew it wasn't matching up to what I know the answer to be. So it's 2.2 divided by 2. That will give you 1.1. But again, it's also on a negative slope. Hence, you would get the answer being D. Okay, last one here. We've got the coefficient of determination is 0.8339. The correlation coefficient is closest to what? Okay, so in this case, what we need to do is we get the square root, because remember, remember that in this case what we're saying is, let me actually move up a bit, it's r squared equals 0.08, oops, 339. So r is equal to the square root of that number, and that will give you 0.913. Now that's actually going to be a plus or a minus, and as you can see that rules out those three, so it could be A or E. Now what you need to remember though is, what gradient do we have here? We have a negative gradient. That means our coefficient, correlation coefficient, is also going to be negative. So that means my answer is A. Okay, so I'm going to stop this video here, and yeah, then next video I'll start talking about the following questions.